Welcome students. In this module we are going to continue the discussion on functions, and let us learn about one of the most important aspects of functions, which we call as recursion. In C we can write functions which are recursive in nature. Now for that we have to understand what exactly we mean by this word recursive functions or recursion. For that, the most popular example that is taken, because it is known to everyone, is the definition of a factorial. For example, if I take n factorial, we all know that it is defined as n times n minus 1 factorial. Do you see that? The factorial of n is defined in terms of another factorial. You are simply saying n times n minus 1 factorial. But still, can we calculate this value? No, we cannot. Again, you will ask, in order to calculate this value, we must know n minus 1 factorial. Now, what is n minus 1 factorial? You will say n minus 1 factorial is actually n minus 1 into n minus 2 factorial. So, as you can very easily guess, this can't go on for infinity or forever. Somewhere it has to stop. And by definition, the factorial of 0 is defined as 1. So this will go on. For example, if you take 5 factorial, it can be thought of as 5 into 4 factorial. This thing can be again written as 5 times 4 into 3 factorial. Still we can't calculate this value. So it will be calculated as 2 factorial. Further, still there is no answer. One times finally 0 factorial. Because this is defined as 1, now this entire thing can be calculated as 5 times 4, 20, 60, and the answer will be 120. So this kind of a definition where one thing is defined in terms of itself is known as recursive definition in general. Now we are going to use the same concept in programming, and the C programming language supports the notion of recursive functions. So we already know about functions. So we are going to know about this special aspect of a function. In C, we can write functions which are recursive in nature. So let us take the example of the factorial itself and try to see how we can write a function which finds the factorial of a given number, but the code is written in a recursive fashion. Again, we will continue with our definition of a function. We are going to write a function. The specific task of the function is going to be, it will receive a number. For example, if it receives 5, it should give the answer as 120. And if it receives 4 as a number, factorial 4 is 24. So it must return a value 24. So it receives one value, returns one value. So depending on that, first we can write the data type or prototype, like this. It returns int. We will name it as factorial. The function name is factorial, and we have to send it one integer value as an input. That's what is summarized in the prototype here. We will start to write the main function. We will simply declare one variable here. Another, we will ask the user, please enter a value. We will read the value typed in by the user using the scanf statement. and then what we do is we make the function call like this. This is the function call, and we have to send the value that is there in the variable n as the parameter. So our intention is that once we have sent the value n to the factorial function, it is supposed to find out the factorial and send back, which we are going to store in f. So in the main function, in the variable f, we will contain the factorial of n. So we will simply put it on the screen. Printf factorial of %d is %d. So factorial of n is f. So this is the main function. Now we have to provide the body of the function factorial, which we are going to do it here. Mind you, this is going to be a recursive function. So in all recursive functions, you will notice that usually there is a test in the beginning itself, which will say just pay some attention to the function body here. Notice that the name of the function is factorial, and in the body of this function there is a function call with the same name. As you can see here, when somebody calls factorial, it is calling itself. So where does this function call go? It comes back into the same function. So this is what we have to understand a little bit clearly. So let us try to see how this program works. So we say that this is a recursive function because the definition of a function contains a call to the same function. So if somebody asks us, how can you say that this is a recursive function? You can say that, see, this function is named as factorial, and inside the body of this function there is a function call to itself, not to another function. So when that kind of a self loop is contained, we say that it is a recursive function. Now let us try to see how this function actually accomplishes the task of finding out the factorial of a given number. Now, as we already know, execution begins with the main function. There are two variables declared here, n and f. You ask for a value is provided, which is put inside. Let us say the value is 4, and it comes to this line here. So in order to put a value into f, first this function has to be executed. Whenever a function call is encountered, we know that the control jumps to that particular function. So it jumps here. While jumping, the value of n is copied into this n here. So the value is 4. Let us take this out. So the value when the first time factorial function is called is 4, and the function is executed. Now let us see what happens. As the function is called, right now the value in n is 4. When the body is executed, this test is carried out. right now this is not true because n is equal to 4. It is definitely not equal to 0. So the control comes here. Just carefully look at the statement here. We can see that this is actually, if we can write the statement here, it is supposed to return a value which is equal to 4 times factorial. This is actually n minus 1. So factorial 3. But can this statement actually immediately return? It cannot, because it does not know the value of this function. So what happens at this stage is that the control again jumps back into the function. But now what is the difference? The function call is factorial n minus 3. So n minus 1, which is 4 minus 1, which is 3. So the value 3 gets copied into n, and at that time what happens is a fresh copy of the function is created dynamically. We call it on the stack. We don't have to get into those details right now, but what you can imagine is that another fresh copy of factorial begins to execute while this is still alive. So while factorial 4 is called, within the factorial 4 function call, factorial 3 is also called because of this function. So when that is entered, we know again n is equal to 3 now. Definitely it is still not equal to 0. So 1 is not returned. Again in that particular function, again that gives rise to something called 3 times factorial 2. This function call in turn will make another function call that will result as 2 times factorial 1. That would be in one function call. This would be in another function. And because of this, again in the freshly called factorial function, this will give rise to n into n minus 1, which is 1 into factorial 0. So we can very easily see when ultimately one final time the factorial is called with a value of n is equal to 0, the body is entered, but at that time this value is equal to 0. So once it is equal to 0, it will simply return the value of 1. There won't be any more, as we call it, recursive function calls. No more recursive calls will be made, or no more function calls will be made, because now this has become true. So finally, when this function call is made, this function call will be replaced by the value returned, which is 1. Why is it 1? Because when factorial 0 is called, it enters n is equal to 0. So that function call will return 1 to the call that is made at that level. So once this is 1 into 1, it will return a total value of 1. And this call is coming from here at the top level. So this total 1 value, which is actually been made because of this function call here, that function call has resulted in this function call. Now this is returning a value of 1. So this entire thing will now be replaced by value 1. So 2 times this is equal to 1. So 2 times 1 will be calculated and the value of 2 will be returned. So this function call will be replaced by 2. Now at this statement, factorial 2 has been calculated as value 2. So 3 into 2 can be evaluated, which is 6. So that value will be returned. So 6 will be returned to this place. And as you can see, now this value is able to return, calculate the value 4 into 6 as 24 and return. And of course, this function call is in the first time it was called with 4. So that is, this is nothing but this here. So in this particular case, it has now become 4 into 6, which is 24. It returns to finally, because everything has started from here, so that 4 into 6, which is 24, is now returned back to this place, which is 24, and the 24 in turn gets copied into 4, comes down here and prints as the factorial of 4. Factorial of 4 is 24. This would be the output. So as you can see here, if a function is defined in this fashion, in a recursive fashion, it receives a value, but in order to compute this function here, it needed to call itself several times. As you can see here, if this is the first time the function call is made, that has resulted in 1, 2, 3 and 4 function calls. Finally, the factorial 0, the recursive function calling mechanism ends at the base, as we call it. So it goes on making function calls, recursive function calls, until it hits the bottom rule or the base case, which is nothing but the value n is equal to 0. Once it hits the case, it gets the value, which is 1. Once it gets the value, it begins to unwind, as we call it. It begins to come back. So as you can see here, it entered with 4 into factorial 3. Factorial 3 in turn made another function call, which is 3 times factorial 2. Factorial 2 again resulted in one more function call, which is factorial 1. Factorial 1 resulted in factorial 0, but factorial 0, it ended there. Because no more, there is no factorial minus 1, because that is how the function is written. So the recursive function calls, they end at that particular point, and once it hits the end, it begins to come back, because now we got a value to work with. So once this is replaced by 1, we are able to calculate 1 into 1, which is 1, that is returned now. Once it can evaluate the value, it returns it back, so on and so forth. So once it hits the end, it begins to come back, and as it comes back, it goes on computing the values, comes back here, and then finally the value is computed. So in a nutshell, recursive functions in C are nothing but functions defined in such a way that there is a function call to itself embedded within the function itself. So it's like a function calling itself. So in a nutshell, we can say that recursion is taking place in a program or in a function when a function calls itself in order to accomplish a task. Let us take one more example of the Fibonacci series, the numbers, in order to understand recursion a little better. Now the Fibonacci numbers are defined like this. They start from 0, the next number is 1. This is the beginning. First Fibonacci number 1 is 0. Second Fibonacci number is 1. Third Fibonacci number is nothing but first Fibonacci number plus second Fibonacci number, which is 0 plus 1, 1. Fourth Fibonacci number is 1 plus 1, which is 2. Fifth Fibonacci number is fourth Fibonacci number plus third Fibonacci number, which is 3. Sixth one is 3 plus 2, 5. Seventh one is 5 plus 3, 8. Eighth one is 8 plus 5, 13. So on and so forth. So as you can see here, the definition of a Fibonacci number is also recursive in nature, in the sense that if I ask you how do you find out or evaluate the nth Fibonacci number, you would say that it is nothing but the sum of the n minus 1th Fibonacci number plus n minus 2th Fibonacci number. That is, 8th Fibonacci number is obtained by adding the 6th and 7th Fibonacci number. 7th is found out by adding the 5th and 6th Fibonacci number. Likewise, so where is it ending? We know that we know the starting point. What is the starting point? First Fibonacci number is 0. Second Fibonacci number is 1. So that is our stopping point. So if anywhere, if we want to know the nth Fibonacci number, we go on finding out the previous Fibonacci numbers as a sum of their previous two Fibonacci numbers, and then finally arrive at the answer. So let us now write a C function, a C recursive function, which given the position, that is, the input would be the position. If I say input as 8 to this function, the answer should be 30. So if 8 is your input, output should be 13. if your input is 6, output should be 5. If your input is 4, output should be 2, so on and so forth. So we ask for the nth Fibonacci number, the program should give us the correct value. Now I want you to see the organization of the functions. Main function starting here, ending here, a small recursive function to find out the Fibonacci number of a given value n. As you can see here, the function is named as Fibo and it returns an integer value, receives one integer value n, and what it returns is the nth Fibonacci number is returned. And what is the logic? Whatever we have mentioned, it is recursively captured here. As you can see here, if n is equal to 2 or n is equal to 1, that is if you are asking for the second Fibonacci number or the first Fibonacci number, we are asking the function to return n minus 1. That is, if n is equal to 2, it will return 1. If n is equal to 1, it will return 0. And we know that first Fibonacci number is 0, second Fibonacci number is 1. And if you give any other position, and obviously we have already defined it as the nth Fibonacci number can be found out as the summation of n minus 2th Fibonacci number or n minus 1th Fibonacci number. So this is how we find. And you can see that this is a recursive function call. Fibo is the function call with n minus 2. When you wanted to find out the nth Fibonacci number, the calls to Fibo of n minus 2 and Fibo n minus 1 are made, and those two are added together. So you can see that double recursion is taking place. So these two are the recursive function calls, because you can see the name of the function here. In defining this function, we are encountering two more function calls which refer to the same function here. So now let us take one example of value 5. Let us say the value of n, that is input, is 5. So the main function receives the value equal to 5 into n, and in the main function this function call is made. So what is the first function call? Let us refer to it as Fibo of 5, which is n basically. So that will make the control jump here, and n will be equal to 5. Now once this begins to execute, we see that to begin with n is not equal to 2, neither it is equal to 1. So this function gets executed, this statement gets executed. For example, what is the statement? It is supposed to return the summation of these two, but we don't have the values of them yet. They are in turn function calls. So when the function enters with n is equal to 5, it results in, we will write it like this: Fibonacci n minus 2 is 3 here, plus Fibo of 4 at that stage. So this will here, this will also come back here. And as we know, as we can see here, when the function is re-entered with value equal to 3, it is again neither equal to 2 nor equal to 1. So 3 minus 2 and 3 minus 1 will be executed, which is nothing but, we can write it as Fibo of 3 minus 2 will be 1, plus 3 minus 1 will be 2. These two function calls that will return in two more recursive function calls. Same way, we can see that Fibo of 4 will result in two function calls, which is equal to Fibo of 2, which is n minus 2, plus Fibo of 3, which is n minus 1. And we know again that Fibo 3 will in turn result in two more function calls, which is Fibo of 1 plus Fibo of 2. Now why did we stop at 1 and 2? Because we know that when this function call is made, when this function is entered with value of n is equal to 1, we know that immediately value 0 will be returned. And also when the function is entered with value n is equal to 2, n minus 1 will be returned, which is 1 will be returned. So this function call immediately returns, this returns, this returns, this returns. Let us see how this entire thing will actually evaluate the value here. We all know that Fibo 1 will return a value equal to 0. It will be added to Fibo of 2, which is 1. So when 0 plus 1 is carried out, that value is again returned. So 0 plus 1 is 1. So that is returned back here. So here it will be Fibo 3 will be replaced by value equal to 1, because Fibo 3, when it is called, it will result in Fibo of 1 and Fibo of 2. When both of them return, they will be added together. So 1 will be returned. So Fibo of 3 will in turn be replaced by the value 1. And when it comes to on the other side, Fibo 4 will result in these two function calls. Fibo 2 will immediately return value 1, but that has to be added to this Fibo of 3. Fibo of 3 in turn will call these two functions. Fibo of 1 will return 0. This will return 1. Those two will be added. So which is 0 plus 1 is 1. So Fibo of 3 will be replaced by 1. This value is already returned as 1. This has now returned as 1. These two values will be added, 1 and 1. So 1 plus 1, which is equal to 2, will be returned here. So Fibo 2, Fibo of 4 will be replaced by the value of 2. Fibo of 3 is already replaced by value of 1. So Fibo of 3 has returned a value of 1. Fibo of 4 has returned a value of 2. Both values are available. So that return statement 1 plus 2 will be carried out, which is 3. So which is nothing but this will be again replaced by value of 3. We can see that 0, 1, 1, 2 and 3. So this is the first, second, third, fourth and fifth. You can see that it has been calculated like that. So you can see here that when a function call is made, it contains 2 recursive function calls, that it in turn will result in more and more function calls. You can see here that only one function call starting from here actually has resulted in 1, 2, 3, 4, 5, 6, 7, 8 calls to the same function. It started with 5. 5 has resulted in 3 and 4 being called. 3 has resulted in 1 and 2 being called. 4 has resulted in fibbo of 2 and fibbo of 3 getting called. Fibbo of 3 results in fibbo of 1 and 2 getting called, so on and so forth. So you can take a bigger number to start with and you can construct the tree and see how the values actually build up, because the bottom leaves will always contain either 1 or 2, because that is our base condition. All your function calls will stop whenever you reach either fibbo of 1 or fibbo of 2. And now coming to what is the order of execution. Order of execution is very simply because always the left one is executed first. We can see that there is A plus B. When you write like that, if this is an expression and this is another expression, C first evaluates this and then evaluates the right hand side. We can see here that this is the left hand side, this is the right hand side. If you can come here, fibbo of 5 will result in fibbo of 3 plus fibbo of 4. So first this thing has to be evaluated, meaning it will result in 1 and 2. In out of these two, this is the leftmost. So this will return first. Then it will fibbo of 2 will return. Those two will be added. It will come back. Once this is evaluated, this thing has to be evaluated. For 4 to be evaluated, 2 and 3. 2 immediately gets evaluated to 1. But fibbo of 3 will be evaluated only with the help of 2 more recursive function calls. Out of these two, this will be evaluated first. So first this, then this comes to here. Then of course in order to do this, it has to find out. So the next this, first this, next this, next this, next this, next this. Once it comes here, added, comes back, those two will be added, and finally the value goes back to the function of fibbo 5. So finally this particular value will be returned back to this place. So fibbo of 5 would be replaced by 3. 3 gets into F and then the value is printed. But in the meantime, that is what takes place inside. So what you can do as an exercise is take a bigger value of n, maybe 6 or 7 or 8, and just construct the tree like this and try to begin to imagine from what I told you that whenever you have this kind of a situation, the leftmost thing has to be executed first. So according to that, you can begin to imagine which one of these function calls. If I ask you a question and give you a tree like this and ask you, out of all these function calls, which one is the first one to return? So obviously it will be the leftmost. So these kind of concepts are going to be touched upon again in your data structures class. But anyway, just to understand this, you simply have to know that the leftmost thing has to be executed first. So once this is over, immediately onto the right hand side. So like that you can build up the recursive tree. So again, to summarize recursion, recursion is nothing but, at least in the context of the C programming language, it is a function calling itself. Now as a student, as a beginner, when we look at a function and if somebody asks you, is this a recursive function? So what you should look for is, okay, what is the name of the function? Fibbo. So do I have a function call to the same function anywhere in the body? Yes. Even if one call is there, it becomes a recursive function. So that is how you can recognize recursion that is taking place in any program. Otherwise it is just like the same as any other functions with regards to either passing of values or the data type or the prototype or other aspects. It doesn't differ, except that it is a function which calls itself. So with that, I think the recursive idea of forming or writing a function, that must be clear to you. Just to summarize, when you look at recursion, it begins with one value, and if the base condition is not met, it results in more recursive function calls. It goes on until the base condition is met. Once the base condition is met, because we get a value at that point of time, the value gets built up as it comes back again. As we have seen here, we go on making function calls, we hit the bottom. Once we hit the bottom, we get the values. Once we get the values, we go up again until the back. Finally, this will return the value equal to 3. So this is how recursion works in the C programming language. I hope you have understood what recursion is and how to write recursive functions. And thank you.